What have we here? Well, it's kind of two things. The first thing, it's a review of basic equations. And by basic equations, I'm talking about what you would usually be called linear equations. In other words, it's just got x's in it. Not x squareds, not square roots of x's. It don't have x in the denominator. Nothing at all fancy. Just x to the 1 power. And it's the old get x by itself trick, right? So it's something that basically you should know already. You should have had a lot of practice with this already before you got to this course. But we're going to review it because it's healthy too. And I said this was two things. First, it's a review. But second, it's a gateway review. A gateway quiz. This is a kind of quiz where the idea is you should know the stuff so well that we don't even have to give you partial credit. We can just give you a test with 10 questions on it, 11 questions on it, and you'll get maybe one wrong, but the rest of them will be perfect, okay? That's kind of your goal here, is to be able to solve these equations perfectly. You're not just trying to get a lot of partial credit. You really know how to get the final answer perfectly, and you could do it. So actually, the first thing to do, before I show you how to do all these problems, the first thing to do really would be to print this out. If you look down at the description of this video and you hit the More button to open it up and see the full description of this video, you will see there is a link to this file. You can print it out. Print it out, take the quiz. It is 11 questions. Give yourself 20 minutes, set the timer. No book, no notes, no calculator, no nothing. Just give it a twirl. The best way to know your status is to actually try these problems cold and see, do you run into any issues or not? And then, of course, you want to come back and check your answers. So we'll just pause and let you try that. Back already? Okay, cool. Let's answer these things. We've got 11 questions to do here. Okay, so I see this nice linear equation here. I want to get x by itself, basically, solve for x. And the first thing I'm going to do is I'm going to get rid of parentheses. So this part I'm not changing anything. But you remember this idea of distributing the 3 up against the parentheses means 3 multiplies everybody that's in there. So you get the 3 multiplies the x, and then also the 3 multiplies the -1, and you're looking like this. If I want to do just one step at a time, then the next step I'm going to do is I'm going to, over here, I'm going to combine these two like terms. They're both just number terms. Remember, x terms can add together, number terms can add together. So since they're number terms, I'll add them together. So I'll have my 3x still sitting there, but the -2 minus 3 will combine to a -5. You'll note that I did not combine the -2 and the -3 with the 8. No, I didn't. Why not? And it's because of this equal sign. When you're combining like terms, you have to stay on your side. Stay on your own side of the equation when you do that kind of thing. Okay, so notice the equation basically looks a little nicer every time. Okay, what am I going to do here? Well, here, what I'm going to do, I usually like to have my x terms on the left, and since there's an 8 over there, I don't want that, so I'm going to subtract 8 on both sides. And now what have I got? The left side still has a minus x. Please do not lose your minus signs. On the right side, I have a 3x. And the -5 minus 8 combined to -13. Okay, now on the right side, I don't mind having the -13 here. What I don't like is having the 3x there. So I'm going to actually subtract the 3x on both sides. So on the left, you see -x minus 3x. Those are like terms. They add together. You get -4x. On the right, you have just a -13 remaining. The last step is to divide by that -4 on both sides. And so x is equal to, and the negative divided by a negative becomes positive, and you've got 13/4. Beauty. By the way, in this college algebra course, improper fractions are nice. Reduced, always reduce, but of course nothing goes into 4 and 13. Always reduce if you can, but you don't have to worry about calling that like 3 1/4 or anything. No, 13/4 looks great. I get so thirsty these days. One down. Okay, hopefully you got that one. Let's try this one. What makes this one any different? Well, again, we're going to get rid of parentheses. And what does make this one slightly different is you have to remember that this is kind of like having a -1 in front. And this -1 multiplies both to give us a -3x and a -2. Some people forget the minus on this 2 here, but it's a -1 times a 2, it's a -2. Now it's going to feel quite similar to the other one, because on the right side I'm going to subtract, I'm going to combine really this 8 and this -2. Those are like terms. They're both on the same side, so I can combine them. I'll have my -3x. I like to put the x term first. And then the 8 minus 2 gives me a +6. Cool. On the left side, I don't like that -7, so I subtract that on both sides. I got a 2x. Over here, I got a -3x. 6 take away 7 is -1. Now looking at the right side, I don't want a -3x, so I do the opposite. I add 3x on both sides, and what do we got here? On the left, 5x. On the right, -1. The last step is to divide both sides by the coefficient of x. That's what that's called. It's called a coefficient. It's not just x, it's 5 times x. I don't want 5 times x. I want x by itself. So I do the opposite of times 5. I divide by 5. And I get -1/5. Beauty. Beauty way to go. 2 down. What's this one? This one's a little longer. Okay, well, kind of know what to do here, right? First, get rid of the parentheses. So this is kind of like having a -1 in front. So I've got a 4. -1 times x is -x. -1 times -1 is +1. And then -2x. Whoa, a lot of stuff on that side. On the other side, I got a 3x. Here I'm distributing. 2 times 2 is 4, and then a 2 times a -x is a -2x. Cool. Let's combine some like terms. How's about? Now make sure you stay on your side when you do this. So on the left side here, these are both on the left side. I can put those together. That'll be a -3x. I can also, maybe I should change colors here or something. I can also combine the 4 and the +1. That'll give me a +5 over here. Meanwhile, over on the right side, let's change colors again. Okay. I got a 3x and a -2x. So those will combine to give me a +1x, right? So just x. And then I got the +4 all by itself. Cool. Boy, that simplified things quite a bit. On the left side, I don't like that 5 there. Somebody added 5. I don't like that. I'll do the opposite. I'll subtract 5. So that gives us a -3x. +5 - 5 go poof. Over here I got x. +4 - 5 is -1. Woohoo. On the right side, I like the -1. I like numbers on the right. I don't like x's on the right. I don't like x terms. So somebody added an x term. We're going to do the opposite, which is to subtract the x term. On the left, -3x - x is -4x. On the right, x's go poof, -1. Now, last step, divide both sides by that coefficient. So notice you get x by itself because both a negative and the 4 both cancel. And over here, a negative divided by a negative is a positive. So just write positive 1/4. Are we flawless so far? That would be cool. That's 3 down. Wow, get 8 to go, huh? Okay, well, let's just keep cranking. What's going to happen here? Well, we got some more distributing to do. 7. 2 times 2x is 4x. 2 times -3 is -6. Equals. Here I got a 4. Distribute the 3. 3 times x is 3x. 3 times -1 is -3. Cool. Combine like terms. Again, stay on your sides. So on the left side here, I got a 4x term all by itself, but the 7 and the -6 make a +1. On the right side, combine, let's use a different color. I got these 2 constant terms, number terms. Those go together. So I got a 3x by itself. And then the 4 - 3 makes a +1. Okay, cool. Now, I don't like this -1 here on the left, so I'm going to subtract it on both sides. Remember, what you do to one side, you do to the other, and everything stays hunky-dory. So notice the 1's cancel on both sides. So I've just got 4x equals 3x. It's looking a little funny, but just keep doing what we've been doing. As I say, on the right side, we don't like x terms on the right side. I'm going to subtract the 3x on both sides. Now what am I looking at? 4x take away 3x is just x. And on the right, 3x take away 3x leaves nothing. 0 is the number that means nothing. X is nothing, or x is 0. Huh, how about that? X is 0. It happens. It happens. Okay, let's see what happens here. The left side, there's really nothing to do at the moment, so I'll just copy it as is. But on the right side, we got something to do anyway. I got a negative 7x, I got a plus 10, and I'm just going to go ahead and distribute this 4 here. So 4 times x, yep, 4 times negative 3 is negative 12. Groovy woovy. This is the combine like terms phase. Now on the left side, there are no like terms to combine. X terms and, see, that's an x term, that's a constant term or a number term. They're not the same, they don't add. Leave them alone, leave them separate. On the right side though, I got these two x terms that I can put together. Negative 7 plus 4 makes a negative 3x. And then I also have these constant terms or numbers that can go together. A plus 10 and a minus 12 makes a minus 2. Okay. Now, looking at the left side. Again, I like having an x term on the left. What I don't like is having a number on the left. So I'm going to add the 2 to both sides. What have I got? I got negative 3x left over here. Over here, I got negative 3x. And notice the minus 2 plus 2 go poof. Huh, interesting. This is kind of like what we had before, right? So we just don't stop. We say, okay, I got a negative 3x. I don't like it there, so I'm going to add it on both sides to get rid of it. Now here's where it gets funky. Because on the left side, if you take negative 3x and 3x, you get nothing. Nothing. They cancel each other. Nothing. And on the right side, if you get negative 3x plus 3x and you add them together, you get nothing. Nothing. Nothing equals nothing. What do we say here? Do we say x equals 0? No, we don't say x equals 0. We've got something that's called an identity or a tautology or whatever. There's different words for this. I don't care whether you know the word necessarily, but you'll hear the word, so you might as well hear it here too. The answer here is all real numbers. In other words, x can be any real number. That might be a better way to say it, really. X can be any real number. In other words, this equation up here is automatically true no matter what you plug in for x. And I would invite you to do that as an exercise. If you were to plug in x equals 1 here, 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 you would get some number on the left side, you would get some number on the right side. They would be the same. The equation would be satisfied. If you were to plug in x equals 2, here, 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 you'd get some number on the left side, you'd get some number on the right side, and they would be exactly the same. The equation would be true. It doesn't matter what you plug in. Trust me, you can even plug in 0 if you want. You can plug in anything. You can plug in negative 57.6. Try it if you dare. It'll work. So in other words, when you come across this special situation, 0 equals 0, or sometimes we come across situations like 1 equals 1, or really we could have said the same thing right here. Look, the left side and the right side are exactly the same. Negative 3x equals negative 3x. They're exactly the same. They're identical, which is where we get this word identity. And what it means is, oh, the left side is the right side. No matter what, the left side equals the right side. Notice right here, I don't care what you plug in for x. The left side and the right side are going to be equal because you're going to take the number and multiply by number 3. What are you going to do? I'm going to take the number and multiply by negative 3. Well, guess what? We're both going to get the same thing. Okay, it's always satisfied, all real numbers. And in order to get this gateway quiz question right, you would have to say all real numbers, or I suppose you could also say x can be any real number. If you want, you can say tautology. If you want, you can say identity. You've actually got 4 options, but you got to say one of those things. You can't just leave it at 0 equals 0. You certainly don't want to say x equals 0 or anything like that. You don't want to say no solution. There's lots of solutions. Look at all these. Look at all the one. Every single number in the world is a solution. You don't want to say no solution. So anyway, flag that one. You want to be ready for that one. Okay. You want to get the question right on the gateways. You need to recognize this situation. Oh, the left side and the right side are identical. This equation is automatically true. It is solved no matter what you plug in. It's going to be solved. There. All right. Let's do another one. Let's see what happens here. So the left side, I'm going to do this distribute thing. 5 times x, and then a 5 times 1 is 5. The right side, there's nothing to do at the moment. So notice I always kind of do the same steps. First, I clear parentheses. I'm going to write parens if you don't mind. It's easier. And then I do the old combine like terms, stay on your side. Sometimes it's handy to write down steps to remind yourself later. So the left side, stay on your side, right? So the left side does have 2 like terms. It has 2 constant terms, 2 numbers. The 5x is there, but the 5 plus the 5 add up to 10 on the right side. Nothing else happening here. So I guess step 3 is I like to subtract number both sides. Does that make? That's what that means to me. Subtract number both sides. So in other words, I don't like this 10 here. I'm going to subtract the 10 on both sides. Make sure that when you're doing this, you are subtracting like terms. So a 10 minus a 10, those are like terms, and they go poof. A 12 take away a 10 is a 2. So I got a 2. And don't lose anything, right? I get this minus x here. I don't want to lose it. So that's what we got now. And then I guess the fourth thing I like to do is I like to add x term both sides. So in other words, I don't want this x term here. It looks like somebody subtracted an x. Well, you take that back. How? Well, add x. That's how you take that back. You do the opposite operation, basically. I see minus x, I add x. Okay, so on the right side, the left side, 5x and x, those are like terms, they go together. On the right side, I got a 2. The minus x plus x cancel, of course. And then the last thing you do is you divide both sides by the coefficient. Now, I've seen people a lot of times say, oh, x equals 3, because they go 6 divided by 2. But be careful here. What you're trying to do is you're trying to take the 6 off the x. Right? This is what you want to do. You want to put a 6 underneath. And 2 divided by 6, you do want to reduce your fraction. 2 divided by 6, you cancel the 2's to get 1/3. X equals 1/3. So that one kind of had a normal answer. Yay. I think we got, what, 8 down, 3 to go? 4 to go? Oof. Wow. 6 down, 5 to go. It's taking longer than I thought. Oh, well, they're all good. Okay, let's take a look at this one. Yeah, I got some just parentheses to get rid of. This is like a minus 1 in front, so I'm going to have a negative 2. Minus 1 times x is minus x. Minus times minus 2 is plus 2. Here, I'm going to distribute this 2. 2 times x, and then 2 times minus 2 is minus 4, and then I get this minus x. Let's combine like terms. How's about? So, right there. I got the negative x, and then actually the negative 2 plus 2 go poof. They add to 0, right? You don't have to write 0. And then on the right side here, I got a 2x, which is a like term with the minus x. So 2x minus x is just x, minus 4. Okay, cool. The left side's looking okay. The right side, I don't want that x there, so I'm going to subtract x on both sides. Okay. So careful now. This is a minus x again. That's like a minus 1 again. It's a minus 2x. And over here, I got a negative 4, right, because those x's go away. Divide both sides by negative 2. X equals, now the negative by the negative makes a positive, and the 4 divided by a 2 makes a 2. X equals 2. That's a nice solution. Let's try this one. Distribute time. Negative 3x. Whoops. Negative 3x. We have a 2 times x. 2 times negative 3 is minus 6. Over here we got an x. And then this is like having a minus 1 here, right? So minus 1 times x is minus x. Minus 1 times 9 is minus 9. Like terms. Those are like terms on the same side. So negative 3x plus 2x is negative x and a minus 6. Over here, well, looks like the x and the minus x are just canceling each other. So I've just got a negative 9. Okay, let's add 6 to both sides. What do you say? What do you say? Negative x. Negative 9 plus 6 is negative 3. Okay. I see people just circle this and go home. You shouldn't really circle this and go home. We're not done. We want x. We don't want negative x. We want x. So what you can do, well, if you want to be official about it, you could say, hey, I'm dividing both sides by negative 1. So the negatives cancel. Negative divided by negative is positive. There you go. X equals 3. Please don't just leave this. That's grody. Grody. We don't want grody in math. Math is supposed to be elegant, not grody. Of course, the other thing you could do is you could multiply both sides by negative 1. So negative 1 times x is x. Negative 1 times negative 3 is 3. That's another approach if you want to. It's probably best just to say, hey, I divided the negative 1 on both sides. Okay. Moving right along. What do we got here? Okay, distribute 3. Let's do it. 14. 3 times 2x is 6x. 3 times negative 5 is negative, 15. There we go. Here, distribute. I got a 6x plus an 8. So on the left side, the 14 and the minus 15 are like terms. Put them together. So I got the 6x, and then 14 minus 15 is minus 1. Over here, I got 6x plus 8. Fine. I don't like the minus 1. Somebody subtracted 1. I'm going to annihilate that, so to speak. I'm going to do the opposite. I'm going to cancel it. I'm going to add 1. So 6x minus 1 plus 1. Poof. 6x plus 9 over here. On the right side, we don't want that minus 6x there. Okay. So on the left, I got 6x take away 6x. Now that's nothing, right? 6x take away 6x, you got nothing. Put a 0 there because you got nothing. On the right side, you got 9. Okay, look at that. There's no x's here. That's a sign that something's up. This happened before. See if I can scroll back real quick. Where was that? Where was that? Ah, right here. Remember this? Well, let me get a different color going. Remember this? We ended up with no x's. We ended up with 0 equals 0. And in that case, we said 0 equals 0. Of course it does. They're identical. It's all real numbers. This equation's automatically solved. Look what we got here, though. That's not saying 0 equals 0. It's saying 0 equals 9. That's impossible. This is called a contradiction. That's the official word. And a contradiction means you can't solve that equation. Here's what you really write. You write no solution. You can write contradiction if you like, but no solution. Or if you really want to just save on ink, do one of those. That's an empty set symbol. It's a circle, not a 0. It's a circle with a slash through it. It means empty set, which means, hey, give me the set of all the solutions. Okay, it's empty because there isn't one. So no solution is what you would write here, or you can write the empty set symbol. You can say contradiction if you want. But when you have this situation, a complete impossible statement, 0 equals 9. No, it does not. I don't care what kind of calculator you buy, 0 is not going to be equal to 9. It doesn't work. It doesn't work. I wonder if there's a website that, no, let's not do that. Let's not go there. Okay, so a couple more to go here. Let's crank these out, man. Crank them out. Whoa, look at this stuff. Okay, so I guess what we're doing here is we're keeping track of our like terms. 3x take away 5x would be negative 2x. Take away 8 more would be negative 10x. On the right side, negative 3 minus 7 is negative 10. Plus 9 would be negative 1. Huh. Okay. Sometimes people here would say x equals 10, but be careful. You want to make sure that you're getting the x isolated. And in order to isolate that x, see right now it's being multiplied. that says negative 10 times x. The opposite of negative 10 times is to divide by negative 10. So this is how you isolate the x. I think of it as canceling. I'm canceling off the negative 10. On the right side, the negative divided by a negative makes a positive. It's a positive 1/10. Okay, cool. I hope this is the last one. Okay, good. This is the last one. Thank you. Phew. Okay, one more. Here we go. Okay, well, yeah, we got some distributing to do. So 8, that's a minus 1 times 6, and it's a minus 1 times 2x. Over here, 14 minus 10x. On the left side, we can combine these two like terms. They're both constant terms. They're both numbers. 8 minus 6 is 2 minus 2x. Here I got a, well, those are not like terms. Do not combine them. Now what? Well, I think on the left side, I'm going to get rid of that 2. It's being added, right? This is a negative 2x with a 2 added to it. So the opposite of adding 2 is to subtract 2. So I'm subtracting 2 on both sides, leaving me this negative 2x on the left. And over here, 14 minus 2 is 12 minus 10x. Cool. Looking at the right side, I like the 12 there. I don't want to have somebody subtracting 10x on me, so I'm going to add 10x on both sides. Negative 2 plus 10 makes an 8x positive. Equals just a 12 now. What's divided by who here? Well, there's the x. I need to cancel 8's on both sides. X equals 12 over 8. Do you see how to reduce that? Cancel what? Cancel 4's. I hope you saw that. 12 divided by 4 is 3. 8 divided by 4 is 2. Here's your final answer. X equals 3/2. Your answers should always be reduced. If they're fractions, they should be reduced. Top heavy is fine. You don't have to write 1.5. In fact, this is actually preferred in an algebra context, a college algebra context especially. It's just easier to work with 2-part numbers. A top and a bottom is fine. 3/2, but do reduce. So 3/2. Woohoo! Okay, so hopefully you got a perfect score on that, and if you didn't, hopefully now you recognized a mistake that you made, and you'll be ready to do this. You have 20 minutes to do 11 of these problems, so that's more than a minute each, way more than a minute each, more than a minute and a half each. So, yeah, good luck to you on that one.